All right, this is the first example of chapter 7. It is question 135. By the way, there's a few example in the course slide before question 135, but these questions are really straightforward. I'm going to do a question that is slightly more complex, not that much. That is, in my opinion, a good introduction to the concept of capacitance. So like I mentioned, it is question 135 on page 14. Let's read the question. So given some value, so by the way, there's a diagram. So we have a ground, we have 3 power source and 3 capacitor. We see in a diagram, a similar diagram in the previous chapter, except instead of capacitor, we had resistance. We will see the logic is really similar though. Okay, so given that V1 is equal to 2 volt, V2 is equal to 4 volt, V3 is equal to 3 volt, C1 is equal to 1 microfarad, C2 is equal to 2 microfarad, and C3 is equal to 3 microfarad, calculate the charge on each capacitor. Now, we're given some value here, and just like we did in the DC current circuit chapter, the last chapter basically, we can create a kind of ohms table. In this case, it's not an ohm table because it's related to capacitor, but you will see that it's really similar in this case. Now note that the formula for the capacitance is C is equal to the charge divided by voltage. We can also use that format. I think it's more intuitive that way. So capacitance multiplied by voltage is equal to the amount of charge. Okay, so we were given a different value for the capacitance. C1 is 1 microfarad, C2 is 2 microfarad, C3 is 3 microfarad. All right, so these are our starting point, and we're given some hint on the diagram on how to figure out the voltage. So let's write the voltage on the battery. This one is 2 volt, V2 is 4 volt, V3 is 3 volt. Yeah, 3 volt over here. So, all right. Just like we did in the previous section, let's define or find what is the voltage on each wire. We can already know that one because it's connected to the ground. This is 0 volt. This one over here, this wire, if this is 0 volt, we get a bump of 2 volt. This one is 2 volt. We got this one over here. Now 0 plus 3, this one is at 3 volt. And there's something weird here, but you will see that it is possible. This power source is increasing the voltage by 4 volt. That means this side is 4 volt higher than that one. Well, that's a bit weird. That means this one is at minus 1 volt. And that's totally possible, by the way. So I said that on the surface of the earth, there are some charge. Even though it's already 0, it's possible to have a voltage lower than 0. Like nothing prevent this, okay? So in this case, that's a good case of the top wire has to be at minus 1 volt. Okay, now we got the voltage on each wire. We can find the voltage on each, or the voltage difference on each capacitor. Just like we did with the resistor, what matter is the voltage on the 2 sides of the capacitor. So let's look at C1. We got 2 volt here, 3 volt here. Well, this one is really straightforward. It is 1 volt. The difference of potential on this capacitor is 1 volt, which means that we've got 1 microcoulomb of charge. All right, let's look at the second capacitor, this one. Well, we got minus 1, we get 3. There's a difference of 4 volt. 3 minus 1 is equal to 4. So we got 4 right here. So that means we got 8 microcoulomb of charge. And finally, the third capacitor is 0 volt and minus 1. There's a difference of 1 volt. So 0 minus 1 is 1. And this one will be equal to 3 microcoulomb. All right. Now, this is fairly straightforward. We can use the basic formula to find the charge. Just as we did, we use something that looked like an ohms table, same logic. Just something to note, the polarity of the capacitor will be pointing in the direction of the highest voltage. So in this case, the capacitor will be pointing, the positive will be on the same side as the highest voltage, so plus minus. In this case, that will be plus minus and plus minus. Now, it's highly unlikely, actually I don't think I will ever do that, but I will not ask you to define the polarity of the capacitor. Most of the time that really don't matter for much of the application where we could use a capacitor. But it is important to have an idea of how we can calculate the charge on a capacitor. Now note, even though it's not mentioned in this problem, we have to assume that once we open the power and we start charging the capacitor, for this to be true, there has to be a substantial amount of time that have passed by. Most of the time, a capacitor in 1 microfarad will charge in far less than 1 second. So if you, in reality, if you open the power, by the time you take your instrument and take a measurement, it is fully charged. But we have to take this into consideration. On the test, you will have question on capacitor, and for sure I will tell you the time. Is it a very long time? Did we just open the interrupter? All these can be quite important, and we will solve many examples later on that highlight this. All right, so we are done with the first example. Let's move to another example.